Okay, so a molecular formula is the non-reduced chemical formula. And we'll say it's usually covalent. Okay, so if we had an example that looked like this, which one is the empirical and which one is the molecular formula? This is the molecular formula, and this would be the empirical formula, right? The empirical formula is the most reduced version of a molecular formula. So you only have one empirical formula for each combination, each ratio, right? This empirical formula, C2H, right, that could have lots of different molecular formulas. C4H2, C6H3, C20H10, right? Whatever it is, as long as the ratio is 2 carbons to 1 hydrogen. So any of these would be considered molecular formulas when there's only one empirical formula for that ratio. Does that make sense? Okay. So we're going to look at the steps now to finding a molecular formula. You cannot find a molecular formula without having its empirical formula first. So all the stuff we did last class of converting grams to moles, then dividing by our smallest number of moles, that stuff will still carry into today's lesson. We're just taking it a little bit further, okay? So you need to start with the empirical formula. Sometimes that will be given, and sometimes you will be given like the percents, and you'll have to find the empirical formula itself, right? So sometimes it will be given, and sometimes you'll have to find it. Okay, so once you have your empirical formula, your next step is going to be to find the molar mass of the empirical formula. Okay, so the reason we do that is this is how the question might be read. It might say, we have an unknown compound. We have an unknown compound that has a molar mass of 300 grams per mole, right? And so this would be the molar mass of the molecular formula. Right? So what we're going to do is we're going to look at how the molar mass of the molecular formula compares to the molar mass of the empirical, and then we'll be able to distribute that ratio throughout. So once we find the molar mass of our empirical formula, our next step will be to divide basically we're going to take the molecular molar mass Okay, so MM just stands for molar mass. Divide the molecular molar mass by the empirical molar mass. Okay, this calculation should always come out to a whole number. Okay, if it does not come out to a whole number, that means we did something incorrectly. Right? It should come out to a whole number or really close to a whole number, because that tells us how big our molecular formula is compared to our molar mass formula. Okay, so let's say, for example, these are made up numbers. Our molecular molar mass was 300, our empirical molar mass was 100. That means it's 3 times as large as its empirical formula. Okay, so if its empirical formula had been, A2B3, right, we would take that whole thing times 3, and we would get A, how many? A6 to B9. Okay, does that make sense? Those are made up compounds. But that's why we use the ratio, right? The empirical formula is the most reduced version. The molecular formula is the bigger version. Okay, so we're looking at that whole number ratio to tell us how much bigger is this molecular formula than the empirical. That's the goal. Okay, does that kind of make sense? Okay, so get out that in-class handout that I gave you last time, and we're going to use the backside today for some molecular formula practice. Okay, so that's just the one I handed to you last class. All right, it tells us that our empirical formula is CH2O, so it already gave us our empirical formula. Okay, so it did most of the work for us. Once we have our empirical formula, the rest of the process is extremely simple. Okay, so we've already got our empirical formula. We need to find the molar mass of CH2O. Okay, because it tells us the molar mass of the molecular formula is 180, right? But we don't know what the molar mass of the empirical formula is until we solve for that. Okay, so CH2O, if you don't have your calculator out, go ahead and grab that out, please. Carbon is 12 plus 2 hydrogens plus 16 for oxygen gives us about 30 grams per mole. Agreed? Okay. You will always take the larger divided by the smaller, right? The molecular molar mass will either be larger than or equal to our empirical formula molar mass, right? It will never be different. So what we're going to do now is we're going to take our molecular molar mass, 180 grams per mole, and we're going to divide that by our empirical molar mass, so 30 grams per mole, right? It's always molecular formula over empirical formula. Okay. And that gives us what whole number ratio? 6. Just 6. Right? So 6 is our whole number ratio. So that means our molecular formula is 6 times as big as our empirical. So we need to distribute that 6 throughout this formula, CH2O. So if we distribute that 6, what does our final answer come out to be? C6H12O6. Right? And that's our final answer. Do not leave it just like this. Right? We can't leave it like this. We have to give us our whole final chemical formula. Okay, any questions there? That's all that it entails. Right? Molecular formula, that's all that it is. We're looking at the ratio between the molecular formula and the empirical formula. And we do that using its molar mass. Okay? The way these questions are worded are very similar to everyone we'll see from here on out. Right? It just depends on the what it's looking for specifically. Okay? So let's look at the second question now. Okay, so in this second practice problem, what's different about it? It doesn't give us the empirical formula. So we need to solve for that first. Okay? So this takes a little bit of work, right? Let's go ahead and start doing that. This mass of the whole sample, do we need that anywhere? No, since it gave us each of our components, right? They should all add up to 3.585, but we're not going to need it for any of our calculations, right? It gave us all of our compounds, right? On our homework, we had a couple where it said, maybe one of our compounds was missing, in which case we would need the total, but here we don't. Okay, so it gave us our compound in grams, which is a good start. First step to finding empirical formula is convert all of those to moles. Okay, is that what we had for our empirical formula, CH3O? We've done the hard part. Now the next step is going to be finding our molecular formula. The first thing we need to do is find the molar mass of this compound. Right? Carbon is 12, hydrogen is 3, and oxygen is 16, which should give us a total of 31. Right? Also, it was really similar to the one we just did before. Okay? It tells us in our problem that our molecular molar mass is 62 grams per mole. We want to divide that by our empirical formula molar mass, and we get a ratio of 2. Okay, so that means our final molecular formula should be C, what? 2H6O2. Very good. Okay, could our molecular formula and our empirical formulas be the same? Yes, they could, right? An empirical formula is always most reduced version. Molecular formula could be the reduced version. So if it would have said our molar mass of our compound was 31 grams per mole, we could have our empirical formula and our molecular formula be the same. That's fine, right? Your molecular would just never be smaller than your empirical. Okay? Any questions about that? That's it for notes for today. So that was a short section.